Okay, now we're going to talk about in 10.3 telescoping sequences or series. These are kind of cool. With geometric series, we did the entire evaluation by finding a formula for the partial sums. But with the telescoping series, it takes a little bit more work to get to this, but a lot more writing out of terms. So let's look at example 3, part A. K equals 1 to infinity, 1 over 3k plus 1 over 3k plus 1. No, not plus, minus. Okay, so let's start writing out terms. If you stick in 1, you get 1 over 3 minus 1 over 3 squared. That's the first term. Plus the second term, putting in 2, 1 over 3 squared minus 1 over 3 cubed. Plus the next term, 1 over 3 cubed minus 1 over 3 to the fourth. And it's going to keep going on out until it gets to, well, the nth term, which would be 1 over 3 to the n being going to infinity, minus 1 over 3 to the n minus 1. Now, if we check out what's happening here, and I'm afraid what's going to happen when I start writing on top of this, the second piece of the first term is going to cancel out with the first piece of the second term. So these two right here are going to cancel. And then these two are going to cancel. And then this guy would cancel with somebody else. And it's going to keep happening. The guy right before the nth term is going to cancel with that one. So I'm going to be left with 1/3, that very first piece, minus the 1 over 3 to the n minus 1. So now the question is, what is the limit of that? Because we want n to go to infinity. So the limit as n goes to infinity of 1/3 minus 1 over 3 to the n minus 1. This little piece right here is going to go to 0. So the answer is 1/3. That wasn't too bad. But the trick on this is to keep listing them out until you see what's canceling. So let's look at this next one. K equals 1 to infinity of 1 over k times k plus 1. Alright, the trick on this one is to use partial sums, because if you just write down the terms, you're not going to see what's happening. Because you're going to have 1 over 2, and then you're going to have 1 over 6, and so you're not going to see it canceling out. So we're going to take a little detour, and we're going to say 1 over k times k plus 1 is equal to a over k, partial fractions, b over k plus 1. Now, if you don't remember the shortcut for this, you would be multiplying the whole thing through by a k times k plus 1. And then solving it. And I don't really want to do it that way. The easy way to do it, you look right here and you say k can't be 0. So now you go over to the left side of the equation and you put your finger on that k right there and plug 0 into the rest. And so you end up with 1 over 0 plus 1, which is 1. So that's what a is. Trying to get b, you look right here and you say, oh, b, k can't be a negative 1 there. So you go over to the left side and you go and you put your finger over the k plus 1 and stick negative 1 into what's left, and you get negative 1, and that would be b. That's the shortcut. It's called the finger method. And now we're going to, if I could do it the other way, I would end up with a 1 equals a times k plus 1. I'll put a little line here. Or plus a b times k. So that's 1 equals AK plus BK plus A. Now there's no K's on the left-hand side, so my A plus my B, actually let me write it like this. So this piece right here, A plus B, must equal 0. And then this piece, the numbers, must equal 1. Well, if A is 1, that means B is negative 1. So there you go. So this turns into summation of A was 1, 1 over K, and then B was negative 1, so minus 1 over K plus 1. So now let's list out terms. And I think I'm going to come all the way down and just lose that paper because you'll be able to see what's happening. If you stick in 1, you get 1 minus 1/2. If you stick in 2, you get 1/2 minus 1/3. If you stick in 3, 1/3 minus 1/4, plus all the way out to, the nth term, which would be 1 over n minus 1 over n plus 1. So now if I look at that, I notice that the second piece of the first one cancels with the first piece of the second one. These two right here are going to wipe each other out. Then these two, and then this one with the next one, and then finally when I got to the end, the one in front of it with that piece. So I'm going to get left with 1 minus 1 over n plus 1, and then you just take the limit. So the question is, what is the limit as n goes to infinity of 1 minus 1 over n plus 1? This piece right here is going to go to 0, and so I get 1. And this concludes 10.3.